What is the point of linear algebra exactly? The point of linear algebra is really in the name. It's just the same as the usual algebra that we are all familiar with. What are the solutions? Normally in school we're taught that algebra just allows us to solve equations such as these, like it's not an issue at all. And unlike what many will have you believe, it's not a game of memorizing each individual step in order to come to a final answer, but it's just so much more than that. What you have done really has a meaning. Look at what we have done here, for example. After using algebra to get to the solution of our starting problem, what we have is not just x, but the answer to our original problem, which was, what number do I need to multiply by 2, then add 3, in order to get 7? Magic. You might be saying to yourself, well, what is the difference so between algebra and linear algebra? Well, there are a number of differences, but a really shameless simplification would be to say that where algebra deals with problems of a single unknown, like the one we just considered, linear algebra deals with problems such as these, with multiple unknowns. If this is the first time you're seeing something like this, then it can appear quite intimidating, but it really isn't. I mean, essentially what we've done is we've just spiced up the game by adding an extra level. Whereas before we needed to find one number to solve an equation, now we need to find a way to come up with two numbers this time, which is able to solve both the first and the second equation at the same time. I really want to stress this point because we can't treat both equations separately. They aren't independent. For example, 2 and 4 is a perfectly valid solution for the first equation, but not the second. And similarly, 3 and 22 fit the second equation, but not the first. We know that solution is out there somewhere, and it's our job to find it, so really, how to even start? Well, a common idea in maths is that when we venture into new territory, the approach is always to simplify the problem you have into something that you're more familiar with, or to just simply use what you know. So, let's use what we know. Let's pick one unknown to start off with, bring everything to one side, and what we're left with is a kind of solution for y, but it's a weird solution, not something like we're used to. We'll treat this like a partial solution, since it's not a concrete number. So we'll use this partial solution and input it into the other equation that we have. By the way, this is also where we link them together. Now they're not independent anymore because we have this commonality between them. And after simplifying everything, we get back to familiar territory. An equation with only one unknown. And boom, one found, one to go. Since by doing this we get a concrete solution for x, we can use this to solve our partial solution for y, and make it concrete as well. And from that we get two concrete solutions, two numbers that solve our original problem, which at the end of the day used basic algebra that we already knew. You know, what is the point of algebra? This is it. It's a tool to find answers to problems. Awesome. But we can widen our horizons here. What about solving equations with not just two unknowns, but maybe 3, 6, or possibly even 100 unknowns? The possibilities are truly endless. I mean, let's try to see what happens with 3 unknowns. So, as before, I'll pick z out of convenience, create a partial solution, use this partial solution in the other two equations, collecting terms which are similar and simplifying. Now, if this looks familiar to you, that's because it is. It's essentially the previous problem which I showed you, which luckily enough we already worked out the solutions for. Using these, we figure out the last link in the puzzle. Now, this is great and all, but if we can figure out all these types of problems with the algebra that we already know, why do we need to learn linear algebra, whatever that may be? The issue lies here. Did you notice that we boiled down the previous problem of 3 unknowns into a problem with 2 unknowns? Then 1? We can solve problems with 1 unknown just fine, and after doing that, everything just collapses, working its way up the chain again. The problem is that the more unknowns you add, the more tedious working out the algebra becomes. Not difficult, tedious. Especially if you're doing it by hand. And it's not like you can really get a computer to do this effectively either. It just simply is too much work. I failed to mention as well the elephant in the room. Consider the following problem. Looks quite straightforward, right? It is. But if you work it out, you'll find something weird. The math just breaks. And there was nothing wrong with our methods, just when you look for the solutions to these equations, there are none. They just don't exist. This is shocking. And frankly, it changes everything for us. Before, we could always have that assurance of a solution, but now that's no longer there. We now have to face the real possibility of being left with nothing, after going through a lot of work to get here. What if I told you that there was another, easier way to do this? That we can solve equations such as these, not just of 3 or 5, but possibly any number of knowns, almost as easily as solving this. But that's where linear algebra comes in to save the day. Because it does that, and so much more. It has laid the groundwork for functional analysis, vector spaces, module theory, and frankly, changed the face of the world, and mathematics as we know it.